In the last video, we have seen the construction of analytic function using Milne Thompson method in Cartesian form. Now, in this video, let's see in polar form. So, see the question, construct the analytic function whose real part is r square cos 2 theta. So, since they have real part, u is equal to r square cos 2 theta. Now, if we have given u, then we can find u r and u theta. You can partially differentiate with respect to r and with respect to theta. So, if I partially differentiate with respect to r, cos 2 theta is just a constant, hide this, r square differentiation is 2r into this cos 2 theta. Okay, remember the constant is just treated as a number. So, it's like 5r square. So, we'll just multiply the constant, that's it. Similarly, we are going to differentiate partially with respect to theta. So, which is a constant? R square is just a constant. So, cos 2 theta differentiation is minus 2 sin 2 theta into r square. So, you got u theta. Now, we have f dash of z is equal to e power minus I theta into ur plus ivr. This is our formula. In this, we have ur in our hand. We don't know vr. So, we are going to find the corresponding formulae to find this VR. What is the CR equation? RVR is equal to minus U theta. RVR is equal to minus U theta. Therefore, VR is minus U theta by R. So, we can derive VR by using this. So, minus of what is U theta? Already we have one more minus sign. This minus and this minus will become plus. So, we will get 2r square sin 2 theta by R. Okay, so this minus and this minus became plus and r got cancelled. So e power minus I theta into ur I have written as it is plus I into 2r sin 2 theta. Now we have 2r common for these two terms, we can take it outside. 2r into e power minus I theta into cos 2 theta plus I sin 2 theta. So step 1 we got ur and u theta. Step 2 we will find f dash of z by using CR equation. Step 3, substitute r as z and theta is equal to 0. Okay, so this is a substitution. In Cartesian, we have put x as z and y as 0. Okay, so f dash of z will become 2z. That's it. Now it's easy for us to integrate. Integral of 2z is 2 into z square by 2. Correct? So that 2 and this 2 will get cancelled. We got z square plus c. So this is the solution. Here if you see, even without substituting we got this in terms of z, because cos 2 theta plus I sin 2 theta is e power 2 theta, correct, e power 2i theta. So e power minus I theta into e power 2i theta, if you simplify, 2 into r e power I theta will get, which is nothing but 2 into z. Yeah, this is what mentioned here. So 2 into r into e power minus I theta into e power 2i theta, that is equal to r e power I theta, that's nothing but 2z. So this is without substitution, this is with substitution, but in some problems substitution will be easier, so you can go for it. So step 1, whatever it is given, if v is given, we are going to find vr and v theta, and then use the f dash of z formula, this is same, and then out of 2 CR equation, whichever is required, we will be using it, and then substitute r as z and theta as 0, and finally integrate. Now see this problem, determine the analytic function f of z whose imaginary part is, so they have given the imaginary part, so this is nothing but v. V is equal to r minus k square by r into sin theta. And we hence find the real part of f of z. So normally they will ask construct f of z. So once we got f of z, then it's easy for us to segregate u and v. That's not a big problem. So the procedure is going to be the same. So we've got v, so we'll partially differentiate with respect to r and with respect to theta. If we differentiate partially with respect to r, sin theta is just a constant, and r if I differentiate 1 minus k square into 1 by r differentiation is minus 1 by r square. So this minus and minus 1 by r square will become plus, so we got k square by r square. And v with respect to theta, very simple, keep this term as it is as a constant, sin theta differentiation is cos theta. So we got Vr and V theta. Now what is the formula for f dash of z? e power minus I theta into ur plus I VR. Correct? So here we have VR, which is missing. ur is missing. So ur is equal to 1 by r v theta. Remember the CR equation? R ur is equal to v theta. Therefore, ur is 1 by r v theta. So f dash of z is equal to e power minus I theta into, in the place of ur I am going to substitute this 1 by r v theta plus I VR. So 1 by r into, what is v theta? This function, r minus k square by r cos theta plus I into VR. VR we have written this 1 plus k square by r sin theta. Here in this term we can take r outside. If I take r outside, what I will get? 1 minus k square by r, and that r and this 1 by r will get cancelled. That is why here denominator r is missing. Okay. So from v theta I will take r common, and this r and that r will get cancelled. So we got this term. Now what we have to do? We have to substitute r as z and theta as 0. Yes, if we substitute, what is e power 0? E power 0 is 1. Correct? So 1 into 1 minus k square by z square, because we are going to substitute r as z. K square by z square cos 0. Cos 0 value is 1. And the leftover values will be 0 because sin 0 is 0. So we get only the real part. So 1 minus k square by z square into 1. So this is what we got. Now we got f dash of z. If I integrate, I will get f of z. So 1 minus k square by z square, we are integrating it. So if I integrate 1, I will get z. So this is nothing but 1 dz. So differentiation of constant only 0. Integration of constant, we will get an answer. Z, and then again we have minus k square by z square. Minus k square is just a constant. If I take z square to the numerator, see the same terms I have written, 1 minus k square by z square dz. So I can split this 1 into dz minus k square into integral of z power minus 2 dz. Denominator, if it comes to the numerator, it is z power minus 2. Integral of 1 dz is z minus k square into, here z power minus 2 plus 1 by minus 2 plus 1. So what is minus 2 plus 1? Minus 1. So we have got z minus k square into z power minus 1 by minus 1. So z plus k square by z. Okay. Because z power n, integration is z power n plus 1 by n plus 1. Same concept we have used. So hence we got f of z. If they ask you only to find the analytic function, we can stop with this. But here they have asked us to find the real part, because they have given v, we have to find u. So now this is the overall analytic function. Since it's in terms of polar, we are just going to replace all the terms back, because u plus iv, real plus imaginary, is this. So substitute z is equal to r e power I theta. Okay. So f of z on this side is nothing but u plus iv, and right hand side r e power I theta plus k square by r e power I theta. Just we have substituted z as r e power I theta. What is e power I theta? Now again I am going to split e power I theta as cos theta plus I sin theta plus k square by r into this e power I theta in the denominator, if it comes to the numerator, e power minus I theta. So that I have written as cos theta minus I sin theta. E power minus I theta is nothing but cos theta minus I sin theta. This denominator is coming to the numerator. So now we are just going to simplify. Group the cos theta term, real term. Okay. If I group cos theta term, what I will get? First term r into cos theta. So first term r, this term. And what is the second cos theta term? K square by r. So r plus k square by r cos theta plus I into, what is the imaginary term here? R sin theta. So r, and then here we have a negative sign, minus k square by r sin theta. Okay. So u plus iv is equal to r into, u plus iv is equal to r plus k square by r cos theta plus I into r minus k square by r sin theta. What is this? This is your question v. So what is u? U is nothing but r plus k square by r cos theta. That is a real part. You can write down this as the answer. So this is nothing but u plus iv, and this is your question, and this is what they have asked. Find the real part. So normally in all the problems they will ask find the analytic function. We'll stop with this. In case if they ask like that, very simple. If it is Cartesian, put z as x plus iy. If it is polar, substitute z as r e power I theta and segregate the real and imaginary part. So till now we know how to construct an analytic function if only u is given or v is given by using Milne Thompson method. Now see this problem. Construct the analytic function if u plus v is equal to 1 by r square cos 2 theta minus sin 2 theta. Here it's a combination of u and v. Okay, and they didn't mention Milne Thompson method. So first what we are going to do? Partially differentiate with respect to r. So I will get ur plus vr. Okay, we are going to differentiate only r term. So this completely it's a constant. Multiplication of that I have written that as it is. This term I have written as it is. So now r power minus 2. If I differentiate r power minus 2, what I will get? Minus 2 r power minus 2 minus 1. So minus 2 r power minus 3 I will get. So that goes to the denominator. This is a very simple differentiation. Okay, r power minus 2 if I differentiate, minus 2 r power minus 2 minus 1. So it will become minus 2 r power minus 3. So minus 2 by r power 3 we have written. Okay. So now we are going to partially differentiate with respect to theta. So r is a constant. So we have written the 1 by r square constant as it is. Okay. So cos 2 theta differentiation is minus 2 sin 2 theta. And sin 2 theta differentiation is 2 cos 2 theta. So here cos differentiation is minus sin. Sin differentiation is plus cos only, but this negative sign is coming here. So now we have two negative sign, we have taken that outside, minus 2 by r square sin 2 theta plus cos 2 theta. Easy for us to calculate. Okay. So we have partially differentiated this with respect to r and with respect to theta. And they said construct the analytic function. Analytic function means polar. We know what is the CR equation. What is that? RUR is equal to V theta and RVR is equal to minus U theta. So your first equation is completely in terms of R. Now if I change this equation in terms of R, I can solve these two and get the answer. So my plan is equation 2, that is this equation, I am going to substitute CR equation. Okay, in any one only you have to. Because if you want, you can substitute here, convert everything in terms of theta. So please don't substitute in both the equations, then again you cannot solve it. Okay, so keep this equation 1 as it is. Touch only this equation 2. So in the place of u theta, I am going to substitute minus RVR. Okay, in the place of V theta, I am going to substitute RUR. Since it's u theta plus V theta, I have written RUR plus minus RVR. Just I have substituted. So right hand side we have written as it is, minus 2 by r square sin 2 theta plus cos 2 theta. Okay. So here you can take r common and bring it down here. So UR minus VR is minus 2 by r cube into everything. Now what is your equation 1? UR plus VR. And this is UR minus VR. Name this as equation say 3. So equation 1 and 3, if we solve, what we have to do? This is plus VR and this is minus VR. So if I add equation 1 and 3, VR will get cancelled and I will get UR. If I subtract 1 minus 3, okay, what I will get? VR. Okay. So once you got UR and VR, it's easy for us to substitute in the formula f dash of z. Please try to write down these two equations together and solve it. So 1 plus 3 will give you on the left hand side 2 URs are there. You can see only equation 3 here. Please refer equation 1 also. So if you add, you will get 2 UR, and then the second term that is cos 2 theta will be there. So outside there is minus 2 by r cube cos 2 theta, and there again you will be having one more minus 2 by r cube cos 2 theta. So if I add these two, minus 4 by r cube cos 2 theta. So from this you got what is ur. Bring this 2 down and 1 2 will get cancelled. Similarly 1 minus 3 will give you only sine term. Vr is equal to 2 by r cube sine 2 theta. Okay. So initially when you subtract, you will get 2 Vr is equal to 4 by r cube sine 2 theta. Please be careful with the sign. So Vr is 2 by r cube sine 2 theta. So we have got Vr and also you've got Ur. What is f dash of z formula? F dash of z is equal to, here it is, f dash of z is equal to e power minus I theta into Ur plus IVR. E power minus I theta into, in both the term Ur and Vr we have 2 by r cube common, right? So we have taken minus 2 by r cube outside so that it's easy for us to write it. Okay. So cos 2 theta minus I sin 2 theta we will get. So see this term, in Vr there is no negative sign. Since I have written minus outside, here you have to replace it by negative, so that this minus and this minus will become plus 2 by r cube sine 2 theta we will get. Okay. So please be careful with the simplification, substitute all the values and do more steps to avoid silly mistakes. So e power minus I theta into Ur plus IVR. Ur is having a negative sign, here you can see. So that negative sign I have taken outside, so we have plus cos 2 theta, and here we have a positive sign. Since we have taken negative outside, this will become minus I sin 2 theta. Okay, now it's visible. So after this step, already we have e power minus I theta, and this is cos 2 theta minus I sin 2 theta is e power minus I 2 theta. Okay, so this and this will become e power minus I 3 theta. If this goes to the denominator, minus 2 by r cube e power plus I 3 theta we will get. So that's what I have written. So minus 2 by r e power I theta, r e power I 3, oh my goodness, minus 2 by r e power I theta the whole cube. So r e power I theta replaced by z, so minus 2 by z cube. Now we are going to integrate with respect to z. This is easy. 1 by z cube, this is nothing but z power minus 3. So if you integrate z power minus 3 plus 1 by minus 3 plus 1. So this is z power minus 2 by minus 2, this and this will get cancelled. We get only z power minus 2. If I push it to the denominator, 1 by z square plus c. This is the solution. So this is not Milne Thompson, just we have used the analytic concept, that's it. So these are all like combination of analytic function and just a kind of Milne Thompson, because we will partially differentiate with respect to r and theta, right? So if they have given u and v, combination of that in terms of r and theta, what we have to do? Partially differentiate with respect to r, with respect to theta, use CR equations, solve those two equations and get the corresponding terms, and finally use the formula f dash of z is equal to e power minus I theta into Ur plus IVR if it's in polar form, and integrate with respect to z to get f of z. Now see this problem, u minus v is equal to e power x into cos y minus sin y. Find the analytic function. Okay, so it is in Cartesian form. So what do you have to do? Partially differentiate with respect to x, partially differentiate with respect to y, and then use CR equation in any one. Please use CR equation in any one. So if I substitute in the second one, completely the second one will change in terms of x and y. Okay, so we have kept the first equation as it is and we used CR equations in the second one. Okay, then by adding we got ux, by subtracting we got vx. This problem is very easy. So we are going to substitute f dash of z is equal to ux plus ivx, and always in Milne Thompson you will substitute x as z, y as 0. Remember, here it is not at all required, because if I take e power x common, I will get cos y plus I sin y. This is nothing but e power iy. Then combine these two, e power x plus iy. What is x plus iy? Z, e power z. F dash of z is e power z. F of z, very simple integration, we'll get e power z. So if they have given only u, only v, or a combination of u and v, you can find the analytic function. Thank you.